Okay, so these are some practice questions on organic chemistry. It says the alcohols form a homologous series. The first member is called methanol and the fourth is butanol. This is methanol. Of course, the functional group is OH, functional group, or hydroxide functional group. This is methanol, this is butanol. And it says give two general characteristics of homologous series. We talked about this earlier. Homologous series have a general formula. All the compounds that are in the same homologous series have a general formula. And of course, their chains increase by 1. For methanol, you have 1 carbon atom. For ethanol, you have 2 carbon atoms. For propanol, 3 carbon atoms. That's propanol. For butanol, 4 carbon atoms. So that gradual increment by 1 as the chain increases. And that's also how the property changes as the chain length increases. For instance, they become more viscous as the chain length increases. The boiling point and melting point also increases. They become less flammable. They burn less easily. There's just that pattern for all the compounds in the same homologous series. Then the next quick, all of this is we treated them earlier, just a revision. Then it says calculate the mass of 1 mole of C8 alcohol, the one that has 8 carbons. We can form that, and then we'll be able to calculate the mass. Okay. And then you can get all these ones when we did stoichiometry, calculating molar masses and all of that. So give the name and structural formula of the third member of this series. Of course, the third member will be, the first is methanol, the second is ethanol, the third will be propanol. And then the structural formula is all that we showed earlier. We represented all that earlier in the previous work. Okay, you find that in the previous lesson where we did alcohols. This is the structural formula of propanol or propan-1-ol, where the OH is attached to the last carbon or the first carbon atom from the right. They all belong to OH group, functional group. And this is butanol. In fact, this is actually propan-1-ol because of the position of the OH bond with carbon. It is in the first carbon atom from the right. That's why this is also butanol-1-ol. We talked about that. Okay. So, calculate the mass of 1 mole of C8 alcohol. You can get that by finding the molar mass. Alright. These are some of the practice questions. Now another question says the structures of 6, I'm just giving hints so that you can walk through this and get a better understanding of organic chemistry. The structures of 6 organic compounds are shown. These are the structures. This. Then it says give the name of F. This is F. Obviously, F has 4 carbon atoms or single bond. So that's a butane. Single carbon single bond. So it's a butane. Identify 2 of the compounds that are members of the same homologous series. if they are of the same homologous series, they will have the same structural formula. Okay, we have this is look at this. This is an alkene with double carbon-carbon double bond. This is also another alkene with carbon-carbon double bonds. So A and B all belong to alkene, the same homologous series. So the compounds and their general formula. The general formula of all alkenes. You can find that CnH2n. Which two compounds are isomers of each other? Explain why. Isomers have the same chemical formula, but different structural formula. You can count the number of hydrogen with carbon. The one that has the same formula, the different structural formula belong to the same isomers. Now explain why B is unsaturated hydrocarbon. Unsaturated means they will have a double carbon-carbon bond, which means you can still split the double carbon into single carbon. So it is more reactive compared to F. F is saturated, having single carbon-carbon bond. B has double carbon-carbon bond, which is an alkene. A is also an alkene with double carbon-carbon bond. F is an alkane, which is saturated. A and B are unsaturated with double carbon-carbon bonds. And then it says, explain why B is unsaturated hydrocarbon. Of course, you need to talk about the fact that it's a hydrocarbon because it contains only hydrogen and carbon, and the fact that it has a double carbon-carbon bond, which means it can be split into a carbon-carbon single bond, so it's more reactive. That means it can form other products, like we have in petroleum products. Okay, there are other questions. This question says the alcohol forms a homologous series. The first 5 members are given in the table. Alcohol formula, heat of combustion. Now it says complete the table, complete the equation for combustion of pentan-1 or in excess oxygen. Of course, when alcohols burn in oxygen, we've talked about what they give. That's oxidation of alcohols. They always produce if you remember when we talked about it, oxidation of alcohols, or when alcohols burn in oxygen, one of the uses in fuels. So when alcohols burn in oxygen, they produce carbon dioxide, water, and of course heat is released. Excess oxygen, plenty of oxygen, giving us plenty of heat. That's why it's used as fuels in some countries to power cars. Okay. We talked about other ones. So it says complete the formula, the equation. Of course, carbon dioxide and water will be released with oxygen. You just need to balance the equation. Okay, these are practice questions. It says state 3 characteristics of homologous series other than the variation of physical properties down the series. I have mentioned that in the previous lesson, but just a reminder. Homologous series, they have a particular pattern, they have the same formula, this is what you find among homologous series. They have the same formula, you know. They have the same general formula, and their chain length increases by 1 each time, from methanol, from mate to earth, from earth to prop, from prop to boot. And of course, as the chain length gets longer, the compounds show a gradual change in properties. You know, they can become more viscous as the chain length increases, or their melting and boiling point also rises as the chain length increases. The compounds become less flow less easily as they become more viscous, and they burn less easily. They become less flammable. You know. Okay, so another question says the following are isomers. This and this. Explain why they are isomers. We've answered that. Then draw the structural formula of another isomer of the above alcohol. You know, when you are drawing it, you must ensure that it has the same general chemical formula, the different structural formula. That's what makes isomers. Okay, then this question says the alcohols from a homologous series. The alcohols from a homologous series, the first member of this is methanol, which is this. Give the general formula of all alcohols. You can find it in the previous lesson, or in one of these lessons, or the earlier part of the lessons we've had. You know, so the mass of 1 mole of alcohol is 116. What is the formula? Of course, when you write down the equal to 116, you'll be able to calculate the formula. CnH2n plus 1 is the general formula of all alcohols. So when you equate it to 116 grams, you can easily find the particular alcohol. So if you write CnH2n plus 1 equals 116, and of course C is 12 times N, 12N, plus H is 1 times 2 plus 2N plus 1 will give you 116. So when you find N, you fit all of them into this to give you the particular alcohol. Just to remind you that the structural formula of all alcohol is, let me go to alcohol and remind you, the structural formula of all alcohol is CnH2n plus 1 then OH. Is it CnH2n plus 1 then OH? So when you are writing this, you have to include OH in this. OH, you know, we give you 116. We have the formulas of the oxidation mass numbers of each of these. So in writing this, we should add 16 for oxygen, and then of course 1 for hydrogen. Each of these ones are represented here. This is for these, this is for these, this is for this, this is for this. That's plus 1. Okay, so when you solve this, you get 116. That will now help us to find N, what N is, and then we fit into that. Because the general formula of all alcohol is CnH2n plus 1, then OH, which is a functional group. And if the 1 mole of it is 116, this whole thing is 116. So C is 12, so 12N plus H is 1. So 2N plus 1 for all of H. Then plus oxygen, which is 16, plus hydrogen, which is 1, we give you 116. We solve N. Now he said draw a diagram showing the arrangement of the outer valency electrons in one molecule of methanol. You know, use X to represent an electron, use O to represent an electron, use X to represent an electron in carbon atom, use O to represent an electron from a hydrogen atom, use the dot to represent an electron from oxygen atom. That's the covalent bond, you know, formed. So there are other questions. I will just walk through them. It says a tin is manufactured by cracking petrol fractions. What do you understand by the term petroleum fraction? We've done all of that under petroleum. The next question says complete the equation for the manufacture of a tin from dodecane, which is C12H26. Dodecane, C12H26, with 12 carbon atoms, and of course 26 hydrogen atoms. That's an alkane. Remember the structural formula of the formula of alkane, general formula of alkane, or in the same homologous series, CnH2n plus 2. So complete the equation for the manufacture of 18 from dodecane. All of that we can refer to the previous lessons. So two fractions obtained from the distillation of petroleum are refinery gas and gasoline. State one use of each. Refinery gas, gasoline, you know, where they find practical uses. A tin is an unsaturated hydrocarbon. What do you understand by the following terms? Unsaturated hydrocarbon. We've talked about that earlier. And it says a tin is used to make ethanol. Which of these reactions is used to make ethanol from a tin? We've talked about that. Whether it's the catalytic addition of steam, fermentation, oxidation using oxygen, reduction using hydrogen. We've talked about all that. You refer to the lesson and then pick the correct answer. So draw the structure of ethanol showing all atoms in bonds. You know, then a tin is used to make polyethylene. Complete the following sentence about the reaction. Use the words in the list below. The tin molecules which join to form polyethylene are the, you know, what we call them, monomers. The polyethylene molecules formed are, of course, the polymers. All right. And many other questions. Let me read this one forward a bit and zoom it in. It says alkenes and alcohols are three different homologous series of organic compounds. What is meant by the term homologous series? We've talked about that. It says the structure of some of the alkenes and alcohols are shown. These are the structures. Which of these two compounds, F, G, H, I, J, K, L, are saturated hydrocarbons? Saturated means they have carbon-carbon single bond. You can see F, G, I are all saturated. This one has a double bond here. Shown there's a double bond here. This one is also a single bond. This one has a double bond here. So these two are alkenes, while this one is J and H are alkenes. The rest are single bonds. This one are alkanes, and these ones are alcohol. In fact, F and G are alkanes. H is alkene, you know. K and I are alcohols. All right. So which one of these compounds are the main constituents of natural gas? Of course, methane is the main constituent of natural gas, which is F. It burns easily. It's the most flammable of all the alkanes, because as the chain length increases, they become less flammable. So which of these compounds are alkanes? Alkenes, we've talked about that. Why are two compounds I and K not hydrocarbons? You know, hydrocarbons only contain carbon and hydrogen only. So F and G are hydrocarbons. H is hydrocarbon. I, of course, is not hydrocarbon, it has oxygen in it. K is also not hydrocarbon, it has oxygen. J is hydrocarbon. Okay, as simple as it can be. Then the next question talks about, let me zoom it in. So the structures of some organic compounds are shown. As you can see, and it says which of these compounds are alcohols. We can easily identify them, the ones with OH. Functional group. Okay. Then which of these two compounds are saturated hydrocarbons? Saturated means they have only carbon-carbon single bond. So we can find Q, we can find S, we can find T, even U. They are all saturated saturated hydrocarbons. Hydrocarbon means it has to be a hydrocarbon. So Q is hydrocarbon, so it's saturated. Even though S is saturated, but it's not a hydrocarbon because it contains oxygen. T is a hydrocarbon and it's also saturated. U is saturated, but it's not a hydrocarbon because it has O. All carbon-carbon single bonds are saturated. The ones that are double bonds like P, R are unsaturated because you can still split the double bonds to single bonds. Then it says methanol and ethanol are alcohols in the same homologous series. Complete the following sentence about a homologous series using words from the list. You know, a homologous series is a family of similar dash with similar dash properties due to the same dash group. Okay, it's a similar family of similar dash, similar compound with the same similar dash with similar dash. Okay, I can't give too much information on that. All right, and this one is on petroleum. So what petroleum is a mixture of hydrocarbons. What's the meaning of the term hydrocarbon? We talked about that. So petroleum can be separated into different fractions by fractional distillation. The diagram shows a fractionating column. The fractions are shown by letters A, B, C, D, E, F. You know, the petroleum is fed into this lower chamber through the furnace. Now it says describe how fractional distillation is used to separate the petroleum into fractions. In your answer, talk about change of state, differences in boiling point. You know how fractional distillation occurs. Substances usually in liquid form are separated because of the difference in boiling point. We talked about how this occurs in fractional distillation of petroleum products in our previous lesson. So you go through it to understand this. This is a whole 5 marks question. So it's expected that you need to mention all the necessary points to get the whole 5 marks. Remember, the mixture is fed into this lower chamber where you have the highest temperature, and the mixture is heated. Most of them evaporate because this temperature is above the boiling point of most of the constituents. Some constituents are never melted, so they still are left at the base of this distillation chamber. Some are collected as liquid, some are collected as solid, you know, but most of them are already above evaporated, in other words, boiled at this chamber. So as the vapor rises, they pass through different layers. Each layer is kept at a particular temperature. If it is a temperature at which the vapor can condense, in other words, turn to liquid, it condenses and flows out. So As you rise up the chamber, the temperature decreases. The highest chamber has the lowest temperature. So constituents that can condense at that low temperature will condense at the highest chamber. Of course, the condensation point is the boiling point. So the temperature at which it condenses is its boiling point. So substances whose boiling point are lower will condense at the upper chamber and flow out. So by that, some of the constituents will never condense. So they come out as gas, which of course can be used in natural gas and for other uses. So this is basically how fractional distillation occurs in petroleum products. So these are part of the exam questions on organic chemistry and hydrocarbons.